Well, hello. In this video, we're going to be talking about one of the highest yield topics on the MCAT, amino acids. And specifically, we're going to be focusing on the isoelectric point of amino acids, which is the cross-section between amino acids and pH chemistry, two very high yield concepts. In future videos, we'll go in more depth on other aspects of amino acids. So without further ado, let's get started. These videos, at least as of now, are sponsored by you. So if you're interested in supporting me to be able to continue to make these high quality MCAT playlists, you can support me either via Patreon or by buying me a coffee. Links in the description down below, as well as the links for everything else. So this is the generic backbone of an amino acid. So you can see it all centers around this alpha carbon right here, which is attached to four different groups. So you have your carboxylic acid group right here, your amino group right here, the R group, and the hydrogen atom. Now, all amino acids will have identical groups when it comes to these three groups. However, the R group is what's going to differ between different amino acids, and that's what's going to make amino acids unique and allow us to distinguish one from the other. All right, next let's talk about how we determine the isoelectric point. You're going to determine the PI, or the isoelectric point, from the pKa's of the groups that are capable of either donating or accepting a hydrogen atom. Now, for all amino acids, with the exception of 5, which we'll discuss later, all amino acids can only carry a positive or negative charge on two groups. And those are the carboxylic acid group and the amino group. Now remember, we're going to talk about the other ones that are an exception to this rule, which can carry a positive or negative charge on their R group. So for these amino acids that can only carry a positive or negative charge on the amino group and the carboxylic acid group of the backbone of the amino acid, you're going to calculate the PI by taking the average of these pKa's. So you're going to take pKa1, which is 2.5, approximately 2.5, okay? So it could be 2.3, 2.6, 2.8, but the idea is that you don't need to know the exact numbers so long as you know that it's acidic, okay? And then the pKa2 is going to be about 9.5 because it's an amino group and it's relatively basic. Okay, so what you're going to do to calculate the PI is going to be taking the average of those, so 2.5 plus 9.5 divided by 2, which is approximately 6. Moving on to the acidic amino acids. So acidic amino acids, these include aspartic acid and glutamic acid, although I don't expect you to know these at the moment because we haven't went over the different amino acids. Here I'm more focused on helping you understand the concepts, and then we'll talk in another video about the various amino acids. So in either case, glutamic acid and aspartic acid can carry a negative charge on their side chain because they have a carboxylic acid group on their side chain. So in addition to that carboxylic acid group in the backbone of the amino acid, they also have one in their side chain. Now the pKa of that R group is a bit higher than the pKa of the one in the backbone, but that's kind of irrelevant. They're both acidic. And the way you calculate the PI of these amino acids, aspartic acid and glutamic acid, is by averaging the pKa1 and the pKa of the R group. So 2.5 plus 3.5 divided by 2 is about 3. Remember, it's approximately 3. Like it could be 2.9, 2.8, but the idea is that they are acidic amino acids. Very important for when we apply them to the MCAT in a bit. Okay, and now we have basic amino acids. So determining the PI of basic amino acids, you're going to take pKa-R, which is going to be about 10.5. It's going to be basic because they contain an amino group in their side chain, and these include lysine, arginine, and histidine. Although histidine is a bit of an exception within this exception, so don't worry about it for now. Just focus on lysine and arginine. And the way you calculate the PI of these amino acids is by averaging pKa2, so the pKa of that amino group, and the pKa of the amino group in the R side chain. So you take the average, it's going to be about 10. The idea is that it's going to be basic, relatively basic. Now, how do you remember which pKa's to take into account? It's very simple. So you're always going to take the pKa of the R group, but then if it's a basic amino acid, then you're going to take the pKa2. If it's an acidic amino acid, then you're going to take pKa1. Now this right here is the crux of the matter. This discusses the PI value of proteins and amino acids. So logically, when you put an amino acid or a protein in an environment that has some sort of pH. So like if you put it on gel electrophoresis, that can have a pH of say 3 or 4 or 7, whatever you want it to be, okay? That pH is either going to be greater than the PI of your protein or amino acid. It's either going to be equal to it, or is going to be, the PI is going to be greater than the surrounding pH. So in the first scenario, when the pH of the surrounding environment is higher than the PI of your amino acid or protein, then the amino acid or protein is going to act as the acid because it has a lower PI, thus donating hydrogen atoms to the surrounding environment and carrying a negative charge. If the PI were equal to the pH, so recall in gel electrophoresis, you're trying to induce a charge so that the current can carry the protein. If the pH of the surrounding environment were equal to the PI of the amino acid, then the amino acid is not going to carry a positive or negative charge, and it's not going to migrate on gel electrophoresis. Okay, and then finally, the last scenario you have is where your PI is greater than the pH. In this case, the surrounding environment is going to act as the acid, thus donating hydrogen atoms to your relatively basic protein or amino acid and giving it a positive charge. All right, so this is a very important note, and it's a very important the point of confusion that arises on the MCAT. So they'll ask you sometimes like which amino acids, they'll give you a few options and they'll tell you which ones can contribute to the overall charge of a protein. And you might be tempted to say, well, can't all amino acids contribute to the overall charge of a protein? After all, they all have at least two groups, the amino group and the carboxylic acid group, which are capable of carrying a positive and negative charge respectively, so they should all theoretically be able to contribute to the overall charge or the overall PI of a protein. But the idea is that what's happening when you form that protein or when you form a polypeptide, well, let's assume that these are individual amino acids, and right here you have peptide bonds in between them. Well, what's forming those peptide bonds? Those peptide bonds are nothing but a connection between the carboxylic acid group in the backbone of one amino acid and the amino group of the backbone of the adjacent amino acid. So those groups that can theoretically carry a positive or negative charge are now embedded in these peptide bonds, and therefore they can't contribute to the overall charge of a protein. So the only amino acids that can contribute to the overall charge of a protein are those that are capable of carrying a positive or negative charge in their side chain. Again, you don't have to know these at the moment because we haven't talked about them. We'll talk about them in another video, but I'll just mention them very briefly. Lysine, arginine, histidine, glutamic acid, and aspartic acid. So because even though their backbone is going to be embedded within the peptide bonds, their side chain is still going to be out there, thus contributing to the overall charge of the protein. All right, my fellow pre-meds, that concludes our slide deck for today. This is an extremely high yield topic on the MCAT, so if there's anything that you didn't catch from the first time you watched the video, watch it again, and also reach out to me with any questions you have. You know where to reach me. You got this, go crush that MCAT. If you've found this video helpful and like the way I teach, I'd recommend watching the rest of the playlist. I spent a lot of time making sure that the videos build on one another, so it makes sense to watch them in order. Also, don't gatekeep these videos. If you have a friend who's currently studying for the MCAT, be sure to share the playlist with them. It really helps the channel grow, and I would really appreciate it. Also, did you know that every single video has customized Anki cards associated with it that cover the concepts that we discuss in a video? So if you want a way to be able to actively review the material and retain it for the long run, I've got you covered. If you're interested in accessing the Anki cards or even the slide decks within the videos, then check out our Patreon or reach out to me directly for alternative ways to access the Anki cards and the slide decks. Finally, these videos, at least as of now, are sponsored by you. So if you're interested in supporting me to be able to continue to make these high quality MCAT playlists, you can support me either via Patreon or by buying me a coffee. Links in the description down below, as well as the links for everything else, including the link to our growing pre-med companion Discord community. Thanks for watching, and I'll see you in the next video.